So as we've gone through and learned how to solve equations, we started with one-step equations and then two-step equations. Then we talked about solving equations with distributing and that sort of thing. And then the last type of equation that we need to learn how to solve when we're learning these basic equation solving skills is this next section. So this is 3.5, and here's the I can statement. I can solve equations with variables on both sides. So variables. So that's the I can statement. Let's take a look at the warm-up here. Just kind of a reminder, just a review, combining like terms. Run through and simplify these by combining like terms, if you would. If you want to pause the video and get the answer, that'd be great, and then I'll go through and do them. So here we go. What we do is, remember, we're looking for, they have to have the same variable and the same exponents, if there are any exponents, and then we always write them in alphabetical order with the constant at the end. So we've got 2x minus 5y plus z, remember there's the coefficient of 1 in front there, minus 8z, and then plus 6y plus 4x, and then minus 1. So we've got x's, y's, and z's, and then we've got a constant. So we're going to look for x's that are like terms. So we're going to combine those and we end up with 6x. Then we're going to look for y's. We're going to combine those. Remember rules for combining integers. These are different, so I find the difference. That's 1, and the biggest one's positive, so that's going to be plus y. And again, it might be helpful if you put a light mark through each one of those as you use them, especially with something as long as this. And then we've got a 1z minus 8z, so that's going to give us negative 7z. Done with those guys, and then the only thing left here is just the constant at the end, the negative 1. So that's just a reminder of combining like terms and the order we write them in and stuff like that. Remember, there's no hard and fast rule about when we've got more than one variable on each term. So we've got 5ab minus 5a minus 5b minus 5a, and then plus 5ab. So we've got a's and b's that are the same. So let's see, that's going to be 10 of them. 10ab, done with the two of those, lightly cross them off. Don't scribble them out so you can still see them. And negative 5a minus another 5a, that's going to be negative 10a, and then that minus 5b is the only thing left, so I'm going to circle that, and that's our answer. So we've simplified those expressions here by combining like terms. Now again, just a reminder, we say this all the time, the point of solving an equation is to get the variable on one side all by itself. And until now, we've only had one variable term in each equation. So what would we do if we had something like this? So this equation is 7x minus 3 equals 4x plus 9. So you'll notice that the biggest difference that we've got here is we have an x term here and we've got an x term here. So the first thing we have to do is decide which side we want the variable on. Do we want it on the left or do we want it on the right? So let's take a look at this example. I've got two of the same equations, just a repeat of that right there. And so for A, we're going to solve this by moving the 4x, and for B, we're going to solve it by moving the 7x, and let's see what we end up with here. Now when we say move it, what we mean is we need to cancel this out. We need to get rid of a 4x. That's a positive 4x. So we're going to undo that, or we're going to cancel that out with its additive inverse. So I'm going to subtract 4x from both sides. So if I move this to the other side, it becomes negative. We're going to subtract that from both sides. Those cancel to be 0. And then we end up with a 3x minus 3 equals 9. Notice I don't have to put the plus sign there because it's understood to be positive. And then I just solve it like I would a normal two-step equation. So I'm going to add 3 to both sides. Those cancel to be 0. I get 3x equals, let's see, we end up with a 12 here. And then I'm going to undo the multiplying by 3 by dividing both sides by 3. Those cancel to be a 1. So I end up with x equals 4. So that's the answer. Now again, we could plug that in and double check and make sure that it actually is the solution. But let's move on to this one right here, and let's do this the other way. So on this one, we moved the 4x over here. So what that did is that left us with an x on the left-hand side. So we read off the answer, x equals 4. Let's see what happens if we move the 7x. So if we're going to move the 7x, here's what we'd have. We're going to get rid of that as a positive 7x, so I'm going to subtract 7x from both sides. Again, moving it to the other side is going to make that negative. Those are going to cancel each other off. So we end up with a negative 3 over here. 4x minus 7x, again, different signs, we're going to find the difference. That's going to be negative 3x plus 9. And now I still have a two-step equation to solve, so let's go ahead and solve that. Let's subtract the 9, so we can isolate that variable term. Cancel to be 0, left with negative 3x over on this side, and negative 12 over on this side. Get rid of that timesing by negative 3 by dividing by negative 3. Those are going to cancel, so we get an x on the right hand side, and negative divided by negative is a positive, and 12 divided by 3 is 4. So we get the same answer either way. So what's the difference? Well, there really is no difference. You can solve it either way. You can move them to the left side or to the right side. It doesn't make any difference. But there is a way where you can avoid some mistakes. So in most cases, you'll be less likely to make mistakes if you always move the smallest variable term. So if we've got a choice between moving a 7x and a 4x, if we move the smallest one, meaning the one that is most negative, and by the most negative, what we mean is the furthest left on the number line. So if we were to look at these numbers, so here's 0, here's 4, and here's 7. Clearly 4 is smaller than 7, but if we had a choice between, say, 4 and negative 7, or 4 and negative 3, this is the smaller number because they're further to the left. So when we say the smallest, we mean the furthest one to the left on the number line, or the one that's most negative is another way to say it. So the reason why you're less likely to make mistakes is if we move the smallest one, so we moved the 4x to the other side, you'll notice that we had a positive 3 as a coefficient in front of the x. So we had 3x minus 3. We tend to make fewer mistakes when we're dealing with positive numbers than we're dealing with negative. So for example, take a look at this point right here. We've got 3x equals 12. Everything that's left here is positive. And if we take a look at this one over here, we ended up with the same answer, but we have negative 12 equals negative 3x. So we generally tend to make fewer mistakes when we're dealing with positives. So you can move whichever one you want, but it's going to be a better idea in the long run if you move the smallest one. There are lots of different places where that's going to work out better for you. Okay, so why will you be less likely to make mistakes if you do the problem with this way? Less negatives is the reason for that. Okay, so we're going to solve each equation, and again, shouldn't have to say this anymore, but we always show our work and show our steps for each one of these. So we're going to look at this. We're going to move the smallest one. So we've got a choice between a 3x and a 2x. The smallest one is the 2x, so we're going to subtract 2x from both sides. Cancel to be 0. We're left with an x plus a 5 equals 2. On this one we get lucky because we're left with just a one-step equation. All we need to do now, because we ended up with a plain old x plus 5, is just subtract 5 from both sides, and we end up with x equals negative 3. So there's our answer on that one. We've got a choice between moving a 7m or an 8m on this one. And again, we want to move the smallest one, meaning the one that's most negative. That's going to be this one right here. So we are going to add 8m to both sides. You'll notice that we end up with a positive 15m. That's what we want, a positive. Okay, plus 1 equals negative 29. Now I'm going to pause right here and just stop and think what would happen if we had moved the 7m. We would have subtracted 7m from both sides, and that would have made a negative 15m over here. Again, no problem with that, but it would be negative, and we tend to make more mistakes with that. So let's finish this up. Subtract 1 from both sides, cancel to be 0, 15m. Combine these, that's a negative 30. Divide by the 15 to cancel off the multiplying by 15. Those are going to cancel to be a 1m, and then on this side we have a negative 30 divided by 15, so that's going to be a negative 2, and there's our answer. Alright, let's take a look at this example. We've got a choice between a variable term right here of negative 10y and negative 7y. Again, the one that is the smallest, or in other words the most negative, is this one right here. So we're going to undo that subtracting 10y by adding 10y here. Again, notice that when we move it to the other side it becomes positive. It turns to the opposite sign of what it was. Those cancel to be 0. So I've got a negative 3 here, a negative 12 here, and again, this is what we're looking for. When we combine these different signs, we find the difference. The difference is 3y, and the bigger one's positive. So again, there's that positive coefficient that we're looking for. So we just continue solving using our two-step equation solving skills. We've got a 9 here, 3y here, divide by 3, and we end up with 3 equals y, or y equals 3, either way you want to say it there. Okay, so those are the answers. Now I've got a few more problems to do. So let's take a look here. Sometimes it's necessary to, let's see if we can see what it might be necessary to do before we choose which side to get the variable on. These each have an asterisk by them for a reason. These are not simple two equations with variables on both sides like we had here. We've got 6n minus 7 equals 8n minus n plus 4. Okay, so that looks a little bit different right in here. A minus 15 minus 2a, 13 plus 4a minus 13. Yeah, definitely a little bit different with a couple of things going on each one of the sides. And then this one's really kind of interesting the way that one's set up. So we'll come back and look at that in just a second. So sometimes it's necessary to simplify each side before we choose which side to get the variable on. So you'll take a look here. There's nothing we can simplify here, but I'm hoping as I read through this you notice that these two are like terms. These both have a variable. So what we're going to do is, this side is simplified, so we're just going to write down 6n minus 7, and then let's figure out what this is right here. This is 8n minus n. So let's simplify that. 8n minus 1n would be 7n, and then this is going to be plus 4. Now this kind of fits in the categories we had up above. This is a regular old equation with a variable on each side. All we have to do is choose which one to move. So I am going to move the smallest one, which is the positive 6n. So I'm going to subtract 6n from both sides. Cancel to be 0 here. Negative 7, and then this is a 1n, so this is n plus 4. And then I'm just going to subtract 4 from both sides, and then we'll have our answer. So those cancel to be 0. We've got an n over here. Combine those like terms, those constants, we end up with a negative 11. All right, next one. We have something we can simplify on both sides here. We have an a and an a, so we've got a minus 2a. That's going to be minus 1a, or just negative a. So done simplifying those. There's still a negative 15 on that side, and then over on this side we have a 13 plus 4a minus 13. Remember, constants are always like terms, so I have 13 minus 13. Those actually cancel to be 0, so we're left with a 4a. So you'll notice that we've got a variable on this side and a variable and another term on this side. So on this particular one, let's take a look and think. We always want to move the smallest one. The smallest one happens to be that negative 1a. But if you think about it, it would be smart to move this one over here anyway, because then we'd have the number over here and the variable terms over here. And we're going to see some value to that in just a second. So those are going to cancel. Negative 15. We get 5a right here. Divide both sides by 5. And let's see, negative 15 divided by positive 5 is going to be negative 3. So there's our answer on that one. Okay. Last one, and let's stop and think about this one, kind of in the context of how we did this problem over here. We've got a 2x on this side and a 4x over here. If we move the smallest one, here's what we'd do. We would subtract 2x from both sides. These are going to cancel, and this is where we start to run into some trouble. There's nothing wrong with what we've done here, but some people forget these cancel, but they cancel to be 0. So we've got to write a number over there. There's got to be a number. And then on this side we have a 2x plus 12. And then let's solve this by moving that over so we can isolate the variable term. 0 minus 12 would be negative 12. So we've got 2x over here, and then we're going to divide by 2. So we get negative 6 equals x. So I'm going to circle that, but then I'm going to come back up here and I'm going to erase the work here, and I'm going to go through and do it a different way. So let's think about this. This side has a variable term and a constant, a plain old number. This side just has a variable. So we might be able to save ourselves some work by doing this. Let's just move that variable term. So we get the variable is all on one side, negative 2x, and we've got a number over on the other side, just a 12. And now we're only one step away from solving this. So we're going to divide by negative 2, cancel to be 1, so we've got a 1x, and this is negative 6. So you'll notice that we end up with the same answer, but if you think back and look, we actually solved this in basically 2 steps rather than the 3 that it took before. So keep that in mind. That will happen occasionally. So if we summarize what we're doing here, and this really puts all the stuff that we've been talking about together, we usually simplify each side before trying to solve the equation. And we usually move the smallest variable term. And again, that means the most negative. So hopefully that's enough examples. You can get going on this and get the assignment done. So good luck. Thanks.